Today I'm going to talk to you about an idea called a hypothesis test. And I'm going to give you two examples for how it kind of works, but we're not actually going to do the test. We're just going to talk about the ideas behind it, the concept, if you will, and some of the key words, because there's quite a lot. So you can see here I've got 8 piles of cards, and in each little pile there are 4 cards, 2 of which are red, 2 of which are black. And I'm going to make the claim that I am psychic, and I can predict whether the top card each time will be red or black. My question for you is, how many of these 8 would I need to get right to convince you that I really was psychic and I wasn't just guessing? So, whilst I finish mixing these up, I want you to write down what is the least number out of these 8 that I'd have to get correct for you to think that maybe I do have psychic powers. Okay, hopefully you've written that down. It really is important that you've actually written it down. If you've just pretended to write it down, go and physically write it down, because we're going to come back to it in a later video. Now, a couple of things. In each pack, there are half red, half black, so my chance of just guessing right, if I didn't have psychic powers, my chance of guessing is a half. There are 8 packs. Whether I get one right or not, so let's suppose I've guessed this one and I was right that it was black, that has no effect on the chance that this pile here is red or black. That is still 50% half. Obviously, 8 piles, if I was guessing it's a half, you'd expect me to get 4 right. You just expect me to get 4 right by luck. But does that mean that 5, which is more than you expect by luck, is that enough for you to go, oh wow, yeah, blimey, that was unlikely? Or are you looking for 6? Or are you going whole hog? It's like, no, unless you get all 8, I don't believe you. Well, that's the sort of the idea behind a hypothesis test. Where is the cutoff point for what is sufficiently unlikely to have happened by chance? And that's sort of the basic idea of it. I want to give you another different sort of example. You'll notice that in this one it's how many do I need to get? Do I need to get 6 or 7 or 8? And we're looking at the top end of the numbers. Here is a admittedly slightly bizarre example, but imagine that a company is using a quiz and they're going to try and help to decide who to promote to a higher ranking job. So in this quiz, each of the questions is multiple choice and there's 5 answers to choose from, and only one answer is correct each time. But working here and getting the promotion will mean working longer hours for, frankly, not a huge amount more money. So the bosses suspect that some people are deliberately getting the answers wrong, even though they actually know the answer. And the question here is, so how many would they need to get for you to think that they're deliberately getting it wrong? Now, hopefully, one question that's popped into your head is, well, that depends how many questions there are, doesn't it? Which is great. So let's just put a number on it for now. Let's say there are actually 20 questions in this quiz. If there are 5 possible answers, then the probability of guessing correctly is 1/5. And so you would expect a fifth of 20, so that's 4. You'd expect somebody to get 4 right just by chance. So does that mean that if they've only got 3 right, they're deliberately getting some wrong? Or are you looking for 2? Or what number for this one? What is the highest they could get before you start to think, maybe there's something suspicious going on? So again, I'm not going to actually do this experiment. We're not going to actually work out the answer to that just yet, but we will use that idea later on. So I'm going to refer to the card game, the psychic test, and the company's promotion quiz when I'm looking at these keywords that come up on the next page. So quite a few keywords to get through. One is called the population parameter. So this is a numerical value of the population. So if I was doing the ESP test, the extrasensory perception psychic test, lots of times, well, we think that the probability is a half. So that would be the population parameter. We think it's a half. Is there anything to suggest that maybe my chance isn't a half, and maybe my chance of getting a question right is higher? And in the test, the quiz as it were, then we think that the probability is 1/5. That's the population's parameter. The parameter should be a fifth, but do we think there's any evidence to say that it's lower than that? For the sake of these, is essentially the probability that we think it's supposed to be. Alright, so a test statistic is, well, once you've done the experiment, how many times did the thing actually happen? So let's suppose I've done the psychic test and I've got 7 correct, then our test statistic is just 7. Fairly straightforward on this one. If I got somebody to do the corporate general knowledge intelligence quiz thing, and there are 20 questions, but somebody does it and they get 2 correct, then their test statistic for that experiment was just 2. Alright, so a hypothesis means something quite specific in this case. So it's the word hypothesis, and a plural for hypothesis is hypotheses. It's exactly the same, but that's an E there. So the hypothesis is what could be going on. And we normally start with something called the null hypothesis, which we write as H with a subscript 0. So this is called the null hypothesis. And this will be a statement about the population parameter. So we could say something like, our null hypothesis for the extrasensory perception thing is that the probability really is a half. It's a bit of a weird thing to get your head around, but the null hypothesis is just nothing's really happening. There's no evidence that anything's different, nothing special going on. So the null hypothesis could be the probability is a half. So you'll usually then have an alternative hypothesis called H1. So alternative hypothesis. And this one will depend a little bit on what the investigation is. In the case of the card test, I'm claiming that I'm psychic, so I'm claiming that I'm going to do better than just getting a half of them correct. So alternative hypothesis, you put a colon. So the alternative is that, well, actually, maybe I am better than that. Maybe the probability really is greater than a half. And we'd write it like that. It's a really, really common thing for people to lose marks on for not stating their hypotheses that they are actually testing. So the default is, well, if nothing special comes up, then we'll just go, all right, well, there was nothing to say that this wasn't true. Let's just assume that that is true. And yet sometimes you'll do enough experimenting, or you'll find out a result that makes you think, well, it doesn't seem that that's very likely. Given what just happened, given the test statistic that came out, I don't believe that the probability really was that. It was so unlikely that I'm going to accept the alternate hypothesis and believe that, in the card case, that the probability is greater than a half. Similar ones for the quiz would be, the alternate hypothesis would simply be that the probability is a fifth. I'll just write it like that, H0, probability is a fifth. But in this case, we want to be testing whether somebody's doing worse than you'd expect. So our alternative would be, well, if somebody does particularly badly, maybe their supposed probability of getting it correct is less than a fifth. You'd write it like that. So another thing that's important is the significance level of the test. And this is a percentage, and it's, well, how unlikely does the result have to be before you go, yeah, that was weird. So you might say, a really, really common one is, I want something that is a 5% chance of happening. So we don't have the time, or we're not looking at how to do this right now, but in the 8 piles of cards, it might be that getting 7 is enough. Maybe me getting 7 right is only a 5% chance that would happen, so that could be it. Sometimes you'll be looking at 10% significance level or a 1% significance level. Those are the 3 most common ones. Could be other ones, but 5% is really, really common. So the significance level is to do with how unlikely was it for your test statistic to happen. Where's your cutoff for going, yeah, that's so unlikely, that's the point where I'm going to say, I don't think the null hypothesis can be true. I think the probability must be different to what we thought it was. So you can have a critical region or critical regions, and this is referring to the test statistic. In the 8 playing cards, I could get none of them right, or I could get 1 or 2 or 3 or 4 or 5 or 6 or 7, or I could get all 8 right. And it might be that once we've done the actual maths behind it, we might well find that 7 or 8 is enough to think that I am psychic. And then the region would be 7 and 8. The test statistic results of 7 or 8 would be our critical region. In the quiz test, I'm not going to write them out, but obviously you could get from 0 great up to 20. And it might be that the region of results that make us doubt the null hypothesis, it might be that the region is maybe sort of 0, 1, 2, or 3. Maybe that's enough to make us question whether somebody really would have got that many right if they weren't doing something deliberately wrong. I put region or regions because sometimes you're looking at not whether you got higher or whether you got a lower probability, but just whether it was different to what you were expecting. So it might be that you've been growing some crops and you had their average height for the crop, and then you change the soil, and you just want to know whether it made a difference at all. Did it make them better or did it make them worse? So you might be looking at whether it went up or went down, because you might have regions at the top end and the bottom end as well. And then the critical value, so this is the last keyword for now. This is just the first number that lies inside the critical region. So in this case, from 0 to 8, if we'd done some statistics and found out that our critical region was results of 7 or 8 would make us reject the null hypothesis, then the first critical value is this one here, the 7. So numbers that are 7 or more, that's the critical cutoff point. So that's quite a lot to take in. Remember, the idea is basically you're testing a claim about a population's parameter. What is the probability that something would happen? And then you've got to do some statistics, which I'll show you how to do in a later video. But quite a lot of keywords for you to get your head around, first of all.